Let's 3.1, number 12.
3.1, number 12. Hold on. Yeah. 3.1, number 12. Okay, it's working. Okay. Differentiate the function this. Okay. K R equals e to the r plus r to the e. What we want to do is find k prime r. Or if you want to remind yourself, r is the variable, so dk over dr. Either way. Okay. So if you feel weird, it's e to the x plus x to the e. Okay. Split them. Let's look at one by one. This is going to be e to the r because the derivative of the exponential is this one. That also tells you this one cannot be r to the e. They're different. What's the difference? Well, let's think about it. What do you have here? That's basically x with a number here. So it's similar to x cubed or x squared or x1. It's just this 3 now is a e. Good so far? For this one, the formula you should follow is going to be x to the n equals n x n minus 1. This n works for any number, which is 3, 2. It certainly also works for e. Therefore, the answer for this is going to be z r e minus 1. And there's no more simplification you can do because e is not an easy number. So that's the final answer. Cool. Other questions? Okay, if no more questions, we will continue with our lecture, starting from 3.3. Okay, brief review. It's been a while. Okay, power we can handle. Rational, we have quotient rule. Exponential, we can do. Trig. Okay. After that, power, log, and trig inverse. F plus g minus g, f times g, f divided by g, quotient rule and product rule, f circle g. The only thing left are this, and this. Okay. Now we're at the stage of doing the trigonometry functions. Now for 3.3. Trig. We observe that sin x, cosine x, tangent x, cotangent x, secant, and cosecant. Then suddenly we realize, okay, once we know sine and cosine, these four are nothing but the quotient of sine and cosine. For example, sine over cosine. If we know either and we apply the quotient rule, we will be able to do it. So for later. Moreover, we look at sine and cosine. We know sine is like this. And cosine is basically sine. Shift to the left by pi over 2. Okay, sine x. Cosine x. And basically the next one is this first one, shift to the left by pi over 2. So if you could find the derivative of the top one, you shift the derivative to the left by pi over 2. You find the derivative of cosine. Still okay here? Cool. Then this is also covered. The key is try to find this one. Once you find this one, you can find this. And once you find both, you can find everything here. Okay, through quotient rule. That's our plan. And then we were talking about what's the derivative of this. Okay. We did some calculation to remind you of that. We start from we went to our library of pre-calc. We find this is actually this. If we use the summation formula. The reason we want to do that is because we want common factors here and here, so we can simplify further. Either way, the details in your notes, but we end up having two terms. The first one is this. The second one is this. And we need to find these two limits. We're right at the stage of doing this. And the thing we're trying to show is the limit of this one goes to 1. Okay. Later with this fact, we can show this part goes to 0. Then finally, we have this term left. The answer is going to be cosine x, which matches what we draw. Okay, that's the whole plan. We were here. Draw the unit circle. You have the red. We have the blue arc. We have the green segments. And now we're right at the red is sine h. The blue is the arc. The arc, check your notes, equals h times 1. Which is h, and we have the red is less than the blue in terms of length because it's straight, and of course it's less than something curvy. This implies that that's everything we did on Thursday. Now by squeeze theorem, we want this side. Once you have that, by squeeze theorem, we can know the limit is 1. So now we want to focus on this side. That's where we are right now. 1, h, 1. Let's forget about the red. Only keep, whoa. Only keep the blue and the green. Okay, blue and green. Now what we want to do is we want to compare the area of this and the area of the triangle. So let me see the blue. Area. And the green area. Okay, that's what we're trying to do next. Let's do some simple calculations. Number 1 for the blue area. Well, the area is given by pi r squared, which is the whole circle, times the proportion of this sector, which is h over 2 pi, as we did before. This is pi r squared, and this is just one piece. Okay. How big is the proportion? Well, the whole thing is 2 pi. And this thing is just h, so the proportion is h over 2 pi. Together, the area is given by 1/2 h, because r equals 1. That's the first area of blue. Okay. Now for the area of the green, let's take a closer look. This is the green rectangle, green triangle. Here's h. Take a look here. You know this is 1. Sounds good? So what's the area? 1/2 base times height. All right, what is the base? The base is 1. Now, what is the height? The height is this. Okay, it's pretty easy to do if you just do a simple trig. That is the height over 1 is going to be tangent h. According to trigonometry, which give you this is tangent h. Simplify, we have 1/2 tangent h. A lot of trigonometries here. They're easy, but if you're not familiar anymore, take some time to reflect. Sounds good? All right, we have the two areas. Now we have a fundamental fact. That is the blue area, no matter how you draw it, is going to be less than the green area, according to the graph. Therefore, 1/2 h, which is the blue area, is going to be less than the green area, which is 1/2 tangent h, no matter how small h is. Okay, now let's do the algebra. That means h is less than tangent h. Tangent h, I'm going to do it with sine h over cosine h. Now, remember, we want sine h divided by h. Then I can just divide h on this side, and then I can multiply cosine h on the other side. Then I switch a little bit of the order. Actually, let's not do it. Let's just keep the order to be the right. Noticing that h and cosine h are both positive, therefore you don't have to change the sign. Sounds good? Now let's put them together. We said this is number 1. Where is it? Sine h over h is less than 1. This is number 2. Sine h over h is bigger than this. Putting 1 and 2 together. Okay. Now remember, we want this. Then we should do the same on both sides. All right, cross your finger. Hopefully they match. The right is easy. This is 1. The left, well, it's cosine 0. Still okay? What is cosine 0? Cosine 0, your x value, or if you think about the graph, this is cosine 0 is here. Can you see this is 1? Less than 1, bigger than 1. Therefore, the 1 in the middle is going to be 1. By the squeeze theorem. Whew, that's a lot of work. But finally, we can say the first part is 1. Okay, so let me copy this. And then let's drag it down to what we want. Now, because of the fact we just find, we can finally say, well, this 1 equals cosine x. With the second part. Our next job is to show quickly this goes to 0. Okay, I'm just going to write it down. It's not standard. Just for fun. H minus. The first thing I want to do is I want to times the conjugate. The reason I want to times the conjugate is because I want to create a situation where I have cosine square h minus 1. And the reason I want to do that is because I know a trig identity. That is sine square h plus cosine square h equals 1. Then I can replace the whole top to be negative sine square h using the trig identity. And once I have that, let's split them. The first one, I want to put a negative sign. The second one, I want to put this. The reason is because we know this is 1. And we leave whatever is left. Okay. So the top goes to negative sine square h. We take the negative out. We take one sine h out. We have another sine h left. The bottom we have h. We match the h with the sine. We keep the rest. Okay. Now the answer becomes negative 1. Keep it. This is 1. We just did it. Times this when h goes to 0. That is going to be sine 0. Cosine 0 plus 1. Cosine 0 is 1. So the bottom is 2. Okay. What is sine 0? That is going to be 0. So the whole thing is 0. Okay. If that is 0, this is 0. And if this is 0, this term is not there. So what's the derivative of sine? Cosine. Finally. Period. That's the first one. Okay. For people who has taken AP Calc before, this is the formula they give you. They never told you where this come from. To really get this formula, you can actually start from the, the definition and end up finding two limits. And to find the limit of one of them, you really have to go through all these geometry and apply squeeze theorem. That's why I say in general, squeeze theorem is really difficult because the construction can be anything. Okay, so far we only have the easy case. Less than 1, bigger than negative 1 if you see sine x. But in general, it can be really creative. Okay. But now we have this table. Sounds good? For our class, for now, just memorize this. You don't have to know anything about what I just wrote. It's just for one-time fun. Cool. Now, let's find the rest. We claim that if you find the first one, you will be able to find all the other 5. Let's first start with cosine x. Okay. This is what we did. This is sine. This is cosine. Okay. What we do is shift to the left by pi over 2. All right. And we already know the derivative of sine x is going to be cosine x. Copy, paste. Okay. Sounds good. Then the derivative of cosine should be the whole thing shift to the left by pi over 2. What does it look like? Well, it's going to be exactly the same shape. Like that. That's cosine, right? Shift to the left by pi over 2. Sounds good? Let's see it again. This is for the sine x prime. Shift to the left by pi over 2. Okay. That's cosine prime. What's the formula for that? Well, does it look like sine x? But wait a second, sine x is like that, right? So this is actually exactly sine x, but flipped vertically. So all we need to do is just put a negative sign here. Okay. That's the second formula. Of course, a detailed proof have to go through all the thing again, like cosine x plus h minus cosine x divided by h. It's too much work. Okay. Tangent. Like we said, then quotient. Before we stop here, but now remember, we already know the derivative of sine and cosine. So we can replace this to be cosine x. That's the derivative. Replace this to be negative sine x. That's the derivative. So we can keep continuing. Negative, negative. What's the value of this? Sine square plus cosine square. That's 1. So the final answer which is already good, but we prefer to write it to be secant square, just to make it look nicer. In general, we don't like quotients. Okay, we like something look like an integer. So here's the work. Feel free to copy and ask questions. If you feel good about this, you go ahead and try to find the rest of the 3. You still have cotangent, secant, and cosecant. They follow exactly the same format here. Okay, so let's just try to do it by yourself. Cotangent, secant, cosecant. Each one is a quotient, cosine over sine, 1 over cosine, 1 over sine. Try to do it yourself. All right. Seems like most of you guys finished. Okay. The cotangent one, the second one. Your answer may look a little bit different than mine because technically you can stop here. This is already looks really good. Sin x divided by cosine square. I just go ahead and do some additional work to make it look a little bit nicer. But if this is an exam, it's a question in exam, it's really not necessary. Okay, you can stop here if you just want to answer it. This is just trying to make it look pretty. All right. Okay. I skipped how to find a cosecant, but the steps will be very similar to how you find secant. It's basically just the same thing over and over again. Pick a different formula and put a negative sign. All right. You can finish the rest by yourself. The key is just to go over them for once to understand how all these formulas come out. But after that, let's put them all together. Try to write this table with me and do not look at your notes. Okay, use your brain, use your mind. Okay. Especially if you finish the first column. You should really be able to guess what's going to be the next column. Negative, if this is cosine, I'm going to use sine. Negative, if this is secant, I'm going to use cosecant. If this is secant and tangent, then cosecant and cotangent. That will be all the formula we need for trig. Memorize it. If you proceed to calculus 2, calculus 3, or physics or anything which use calculus, okay, you need to memorize those formulas. You don't have time later to look for them in the book because they're so frequently used. Personally, I memorize them in just the first column. Then you can probably deduct the second column yourself. They look really, really similar. All right, that's it. That's everything about trig. We have 6 of them, but basically 3 formulas and then 3 corresponding formulas, which you can deduct by yourself. Now let's just look at some examples. The first one, try to find the derivative of, let me make it clear, secant x times sine x divided by e to the x plus tangent x prime. That's the first exercise. The second exercise is try to find the second derivative of secant x. With all the formulas we derived, plus quotient rule, product rule, and power rule we did before, you should be able to handle this. So let's spend the rest of the class just doing these 2 examples. Let's check the first one and make sure everything looks okay. It's quite easy to follow once I write everything down. The harder part is when you do it yourself. Can you do things in a structure such that it's difficult for you to make mistakes? Okay. That's the harder part. Okay. Can you write your steps down such that other people can read it and understand what you're doing? For that purpose, nobody enjoying copying all those kind of craps. Even though you don't change them, you just keep copying them. Okay. And it's a pain in the butt. It's tedious, but you need to do it. Because only in this way, if you write, people can understand what you're doing. Okay? So try to write your steps carefully. If there are such things which are tedious to copy down, copy it down to make sure everything right here is correct. It's required by the class, so don't skip steps. Second, in our class, you can stop here. Some people may say, well, there are certainly things you can make better. Okay. For example, if you see secant x times cosine x, let me just say it here. If you see secant x times cosine x, you can write it to be 1 over cosine x times cosine x, which equals 1. So you can simplify further. If you see secant x times sin x, you can certainly do 1 over cosine times sin x equals tangent x, which looks easier. So you can further simplify your answer. Okay. But in our class, it's not that you shouldn't do this. It's more about we want to focus on the things we want to focus on. That is product rule and how to take derivatives. Sounds okay? So for things as complicated as this, you can stop here. Even though we sure know there are certain steps you can simplify further. Okay, especially with trigonometry. You don't see them right away how to simplify things until you try them out. For now, we regard it as unnecessary steps for our class. But in general, of course, you should simplify. But we can just keep it like this. All right, if that is okay, try the second one. And if you have questions, of course, just raise it. All right. That'll be all we need to cover today. Feel free to stay and ask questions and anything. If you feel like you're pretty good with all the 2 examples we show, feel free to leave.